Now let's take a look at some application problems in Objective 5. The first example is to write the area A of a circle as a function of its circumference C. Well, if you recall, area is defined in terms of r, right? It is pi r squared. So right now, area is a function of the radius. So what we're going to need to do is use the circumference formula to rewrite r in terms of c. Well, we know that c is equal to 2 pi r. So we can rewrite r in terms of c. If we divide both sides by 2 pi, that would give us that c over 2 pi is equal to r. Now we can substitute in place of r the c over 2 pi. So we would get area is pi times c over 2 pi squared. So that gives us pi times c squared over 4 pi squared. And now we can divide out a common factor of pi, so that gives us area is c squared over 4 pi. So now we have area in terms of circumference, so the formula A of c is c squared over 4 pi. Okay. Now I would like to work for you a problem from the textbook. It is problem number 73 on page 26, and let me see if I can pull it up here. Okay, it is to say this, that the cost per unit to produce a radio model is $60. The manufacturer charges $90 per unit for orders of 100 or less. To encourage large orders, the manufacturer reduces the charge by 15 cents per radio for each unit ordered in excess of 100. For example, and it tells you there would be a charge of $87 for an order size of 120. The table below shows the profit P in dollars for various numbers of units ordered. Use a table to estimate the maximum profit. So we can go through the column for profit, and as you see, they're increasing up to, it looks like $33.75, and then they start decreasing. So our estimate for the maximum profit would be that it is $33.75. Now the next part is to plot the points from the table in part A. Does a relation defined by the ordered pairs represent P as a function of x? I'm not going to plot these, but hopefully you can see that that does define a function, because for every input there's only one output. Now those output values may repeat, that's fine, but there's only one y value that goes with every x value. Excuse me. Now if P is a function of x, write the function and determine its domain. Well, this is where we need to go back and look at what was given to us initially. And let me just make some notes here on our page. We know that the cost to produce them was $60 per unit. And then the manufacturer sold them for $90 per unit for orders that were less than 100. But for orders that were greater than 100, he did this. He reduced the charge by 15 cents for everything over 100. So that was the charge per unit here. So think about this. Our cost was given as $60 per unit. Our revenue is what the person selling this product is making, is given here. Now, what is profit? Profit is revenue minus cost. So I need to really clean this up a little bit and think about what x is and all of that. So our cost function, if x is the number of units sold, our cost, if we will, C of x is 60x. Our revenue is the price we're selling times the number of units that we sold. So our R of x is 90x if x is less than 100, right? But, in fact, let me put it like this. Oops. Sorry about that. I wanted to make that a bracket because this is really a piecewise defined function. It's equal to 90x for x less than 100, but then it's equal to 90 minus 0.15 times x minus 100 times x if x is greater than or equal to 100. You know what? I said that backwards, didn't I? I'm sorry. This was 100 or less, so let me get that straight. This should be x is less than or equal to 100. And the second piece is defined for values strictly greater than 100. Okay, now the second piece, hopefully it's not too confusing, right? The 90 minus 0.15 times x minus 100, that is how much the person is selling it for, but then you have to remember to multiply that by the number of units sold, so that's why we have that other x there. So we can clean that up if you like. This is really 90 minus 0.15x plus 15 times x. So 90 plus plus 15 is 105 minus 0.15 x times x. So now if we distribute the x, we would get 105x minus 0.15x squared. Okay, so that is an expression for the revenue when more than 100 units are sold. Now, we're not yet done because what we needed to find was profit. Profit is revenue minus cost. So our profit function, our p of x, again, it's going to have two pieces since we have two pieces to the revenue. For x less than or equal to 100, it's simply 90x minus 60x, or we can write that as 30x. And that is if x is less than or equal to 100. And for x greater than 100, we have this expression 105x minus 0.15x squared minus our cost, which was 60x. So if we simplify that, what would we get? 45x minus 0.15x squared for x greater than 100. Okay, so that's a couple of applications. All of these applications are going to be a little bit different. So if you get stuck on any of those, please feel free to contact me and I'll be glad to help you.